In this video of section 14.1, we're going to be evaluating iterated integrals. In this example, our inside bounds of integration, we have the integral from -1 to 1 of the integral of -2 to 2 of x squared minus y squared dy dx. I put parentheses around this inside integral because I want to evaluate that first and simplify before I worry about the outside integral. So the outside integral is from -1 to 1 of all of this, whatever we simplify dx. So I'm going to put a bracket here because we've got some work to do on the inside integral. The inside integral differential is y, so we're going to integrate with respect to y, treating y as a variable and treating x as a constant. When you take the antiderivative of x squared, we're treating x as a constant. The antiderivative of a constant is that constant times the variable y. And now the antiderivative of y squared is going to be minus 1/3 y to the third power. You're going to evaluate this antiderivative at the bounds. Now what I like to do here is I like to write the bounds. The lower bound is y equals -2 and the upper bound is y equals +2. I like to do that so I remember what variable to plug in and the bounds for. And then once you simplify all that is going to be simplified into your outside integral in terms of x. So let's go ahead and evaluate the inside integral. I'm going to first replace the upper bound 2, replacing y equals +2 for our upper bound, and then we're going to replace y equals -2 for the lower bound, and then simplify the result. So when we plug in the upper bound, we get x squared times 2 minus 1/3 times 2 to the third power. That's our upper bound minus what we get when we plug in the lower bound, y equals -2. So that would be x squared times a -2 minus 1/3 times a -2. In fact, I like to put that in the parentheses, -2 to the third power. All of that simplified, and then that would be our dx. Okay, let's simplify this a little bit more. Again, I'm not really doing anything with the outside bounds and the outside differential until I get all this inside simplified. Now when you simplify this, I'm going to get 2x squared here minus a -2x squared. So that is going to simplify to 4x squared. Now this is a minus 1/3 of 8, or -8/3, minus a positive 8/3, so it's a -8/3 minus 8/3. That would give you a -16/3. So that's what you get when you simplify the whole inside integral. And now we have it simplified to a single integral with a single variable. We're going to integrate this with respect to x. When you integrate this with respect to x, treat x as a variable, antiderivative 4x squared is 4/3x cubed. Antiderivative of -16/3 is -16/3x. And we're going to evaluate that at the bounds from -1 to 1. Now when you plug in +1 and then plug in -1 and subtract the results, we get the final answer is -8. So the key to remember in terms of evaluating these iterated integrals is simplify the inside first, and the order of the differentials does make a big difference on how you integrate. Okay, here's another example of an iterated integral, the integral from -4 to 4 of the integral from 0 to x squared of the quantity, the square root of 64 minus x cubed dy dx. Now you can pause the video, try this one on your own, and then come back and check your answer. All right, so let's go ahead and look at the inside integral. The inside integral has the differential dy, so we're going to treat the y as a variable and treat everything else as a constant. And then once we simplify the inside, we will evaluate the outside integral from -4 to 4. So if we take the antiderivative of the inside, the square root of 64 minus x cubed dy, this is, we're treating x as a constant here and y as a variable, so this is all one big constant. The antiderivative of a constant is that constant times our variable y. And then we're going to evaluate this where the lower bound is y equals 0 and the upper bound is y equals x squared. Again, I put those y equals in the bound so I remember what to plug in. There's two variables here. You want to make sure you remember to plug in the right one. And then after you simplify that, that's going to be able to write it as a single integral. Alright, so when we plug in our upper bound x squared in for y, and then plug in our lower bound and simplify, we get the square root of 64 minus x squared. I'm sorry, that should have been a 3 there. Sorry. 3 times our y, we're replacing this x squared, minus what you get when you plug in 0 for y. And if you plug in 0, you get the whole thing as 0. So this is our single definite integral. It's the integral from -4 to 4 of the square root of 64 minus x cubed times x squared. Now this is a great integral for using u substitution. If you let u equal the quantity under the square root, 64 minus x cubed, then your du has to be -3x squared dx. Now the only thing, we have the x squared, but we don't have the -3. So I can put a -3 here, as long as I take a -1/3 out in front. So I can rewrite this integral as a -1/3 of the integral. This is going to be the square root of u, which is u to the 1/2, and your x squared times -3 times dx is your du. Now, another thing I like to do here is change the bounds of integration. For your lower bounds, in terms of the bounds, your lower bound, or LB, was x equals -4. Well, if you've already done the u substitution here, you can put -4 in for x and simplify to get your lower bound in terms of u. So when you plug in x equals -4 into this x and subtract 64 minus the quantity of -4 to the 3rd power, you get your lower bound is 128. For your upper bound, your x was equal to +4. Oops. X was equal to +4, and when you plug in +4 in there, you get your upper bound in terms of u is equal to 0. So this is an integral from a lower bound of 128 to an upper bound of 0. That just saves you a step when you're going back to doing the substitution after you integrate. Alright, so when we integrate this, it's going to be -1/2 the antiderivative of u to the 1/2 du, and that's going to be add 1 to the power u to the 1/2, we get u to the 3/2 times our 2/3, and we're going to evaluate it from the bounds 128 to 0. When you plug in 0, you get 0, so that's going to, and the 2's will simplify. When you plug in 0, you get 0, minus what you get when you plug in 128, and that's going to be -1/3 times 128 to the 3/2 power. Okay, and that is approximately as a decimal. Okay, I just realized I made a mistake here. Did you catch what I did? This -1/3, I end up copying it down as a -1/2. So I apologize for that mistake, and that does change our answer here. It doesn't cancel out, but we get, this should be a -2/9. Let me erase that here. Okay, again, I copied down the -1/3. It should be a -1/3 times the integral. So that's being -1/3 times the 2/3. Those 2's aren't going to cancel out, so that's actually a -2/9. And then when you plug in that simplify on your calculator, that is approximately 300 321.81. Now what you can do is verify that you can check your answer here by going to the step right here before we did the u substitution. You can use the integration feature on your graphing calculator to evaluate this integral from -4 to 4 of the square root of 64 minus x cubed times x squared dx. And then you should confirm that that is the same answer.